Hmm. So let's continue. Actually, there was some issue with the class, and okay. Actually, there was some issue with the internet, and my live class got interrupted, and I was not aware of that. So I've taken the complete class. Now I have to repeat it. So we were discussing this question number 5, and we had committed one careless mistake, one calculation mistake, and finally the answer comes out to be 0.198. So only this last step was left out. So continuing with the sixth question. Now the question is saying that this is an asymmetric three-level mid-trade quantizer. So if it is mid-trade, this means that 0 is a representation level. So this 0 is a representation level. So minus a and plus a are the decision boundaries. So assuming that equiparable occurrence of all quantization levels, this means that area between area between two decision boundaries must be equal for all the decision boundaries. So region 1, region 2 and region 3 are having equal area. So what is the area for region 1? What is its span? This is 2a. And what is its height? Its height is 1 by 4. So if the three regions are having equal area, then see the area under the PDF curve, this is unity, and if the three regions are having equal area, this means that all are having area equal to 1 by 3. So this implies what will be the value of A? A is simply equal to 2 by 3 answer. Right. Now coming to 7th question. 7th question is in continuation with question number 6. In fact, these two questions were common data questions. So we have calculated A. A is equal to 2 by 3. Now the question is asking if the priority density function, the quantization noise power for the quantization region between minus a and plus a in the figure is. So you have been asked to calculate the quantization noise power EQ square, and this is simply equal to, and between the regions minus a and plus a, minus a to a, q square fq dq. Now this is simply equal to, since this is symmetric, we can write 2 over here, and we can change the limits from minus a to 0 to a, and x minus q is simply x minus x cube whole square. And what is a? This is fxx dx. Now for limit 0 to a, the xq is equal to 0. 0 is the representation level. Why? Because this is a mid-trade quantizer. So this is x minus 0 whole square into 1 by 4 dx. From where have we obtained this 1 by 4? This is basically the height. So this is equal to 2 into, we can bring 1 by 4 outside the integral sign, x cube by 3, 0 to a. So this is 1 by 2 into 3, 1 by 6. So this is a cube by 6. So we can write it like this: a cube is equal to 2 into 2 into 2. So this will be equal to 8 divided by so it will be 6 into 3 into 3 into 3. So it will be 27. 2 3s are 2 4s are. So this is simply equal to 4 divided by 81. So its answer is 4 divided by 81. Right. Now coming to the next problem. What is the minimum sampling rate required to reconstruct the signal? The minimum sampling rate fs is equal to 2w, or twice of the bandwidth. Right. Now this is a sig function. By dividing it by 2000, and by multiplying it by 2000 cube, and similarly by dividing it by 2000 and multiplying it by 2000 square. We can get xt in the form of, now this is sinc function. Let us assume that 1000 is equal to b. So we can write it like this: a into sinc cube 2bt plus b into a1, right? You should write that a1 and a2 into sinc square 2bt, where b is equal to b is equal to 1000. Now, what is bandwidth? What is bandwidth of sinc 2bt? Bandwidth for sinc 2bt is b. See, a sinc function has in frequency domain, it has a spectrum. Sinc 2bt has a spectrum which is uniform between minus b and b. So its bandwidth is b. Okay. Now, if a function gt has bandwidth equal to b, then g raised to power nt has bandwidth equal to n into b. So this means that this function sinc 2bt, this will be having a bandwidth of 3b, and sinc square 2bt will have a bandwidth of 2b. So what will be the bandwidth of the signal xt? Let us call it as w. Now this will be equal to maximum of 3b and 2b. This will be equal to maximum of 3b and 2b, so this will be equal to 3b. So this implies the sampling rate, the minimum cycle rate is must be equal to 2w, so this is equal to 6b, or this is equal to 6000 Hz. So option C is right. Now come to the next question, and this is a very good question, and now there is a catch in this question, and many a times the students fall into the trap. Now this function is not the ideal sampling function. The ideal sampling function, this is basically summation n is from minus infinity to infinity delta t minus n ds. Now why this function is not an ideal sampling function? Because you are having a term minus 1 raised to power k over a. Now if we plot this ideal sampling function, you will get sample having weight equal to unity and placed uniformly at a separation of period. Now what about GT? Now let us solve this quantity as capital T. Now what can we say about GT? It will have alternate positive and negative pulses. Because of the factor minus 1 raised to power k, it will have alternate positive and negative pulses at intervals t, 2t, and so on. So what will be the time period of GT? Now in this case, the time period is not t, but the time period is 2t. The signal is repeating itself after 2t interval, so the time period t0 is equal to 2t. Now t is equal to 0.5 into 10 raised to power minus 4. So this implies what will be t0, this is equal to 2t, that's equal to 10 raised to power minus 4 seconds. And what is f0? F0 is equal to 1 upon t0, so this is equal to 10 kHz. Now, there is one more very important thing. Now, this signal exhibits half wave symmetry. GT exhibits half wave symmetry. Now, if GT exhibits half F symmetry, this implies only odd harmonics are present. That is, the DC component and even harmonics are not present. So, what will be the frequency component present in GT? So, therefore, frequency components in GT are ten kilohertz, then 30 kilohertz, then 50 kilohertz, and so on. So, there won't be any DC term or the even harmonic term. Now, a signal, what is the bandwidth of a signal? It is 0.5 kilohertz. Now, let us assume that the spectrum of FT is this. So, it has a bandwidth of 0.5 kilohertz. Right. So, and this signal is multiplied with this signal. So, multiplication in time domain refers to convolution in frequency domain. So, what will happen? Now, now this is our MF, and what will be our GF? So, for GF we will be having impulse function at an interval of at 10 kilohertz, 30 kilohertz, and so on. Now, when we will convolve MF with this GF, let us assume that the function is ST. ST is equal to MT into GT. So, what will be SS? So, what will be SS? So, you won't get any component around the DC or around 0 Hz. So, there will be components around 10 kilohertz. So, the signal, since the bandwidth is 0.5 kilohertz, the signal will be available between 9.5 and 10.5 kilohertz. Then the signal will be available around 30 kilohertz, between 29.5 kilohertz and 30.5 kilohertz, and so on. Now, if we are applying one low pass filter with bandwidth is equal to 1 kilohertz, so there isn't any signal present over there. So, output of this filter will be simply equal to 0. So, option C is correct. Now, coming to the next question. An input to a 6-level quantizer has the quality density function etc. So, this is a boundary that is to maximize the entropy. Now, what is the meaning of maximizing the entropy of the quantizer? Maximizing the entropy means all the representation levels are equivalent. It simply means that all the representation levels are equivalent. Now, 0, -1, 0 and 1 are 3 consecutive diffusion boundaries. So, this means that one representation level is lying between 0 and 1, another one is lying between -1 and 0, and so on. So, for having equitable total representation levels, and there are 6 representation levels, given this 6 level quantizer. So, what is the probability of each representation level? Therefore, each representation level will have a probability equal to 1 by 6. By 6. So area under this curve, area under this curve, area under the PDS curve between 0 and 1, this will be equal to 1 by 6. So what will be the area? Now the span is 1, height is A, so area is 1 into A, and this must be equal to 1 by 6, so this is like A. Right. How will you calculate these? Now total area under the PDF curve is unity. Now since this is symmetric, so for the positive values of x, the area will be 1 by 2. Now this is 1 by 6. This area is 1 by 6. So area from 0 to 5, this must be equal to 1 by 2. So area under this curve, from area to the curve between 1 and 5, this will be equal to 1 by 2 minus 1 by 2, so this is equal to 1 by 3. So we say that area under this, area of this rectangle is 1 by 3. So what is the area of this rectangle? The span is 4 into B, which is equal to 1 by 3. So this is like B will be equal to 1 by 12. So A is 1 by 6, B is 1 by 12. So option A is correct. Now coming to the next part of the question. Now we know that A is equal to 1 by 6 and B is equal to 1 by 12. Assuming that the reconstruction levels of quantizer are the midpoints of the existing volume, the ratio of the signal power to quantization noise power. So it is asking about signal power to quantization noise power, or it's asking about SNR, which is simply equal to EX square divided by EQ square. So let's try to calculate EX square first. Now how will you calculate EX square? EX square is simply equal to minus infinity to infinity x square fx dx. Now since this function is symmetric, so this will be equal to 2 to 0 to infinity x square fx dx. So this is equal to twice of 0 to a, no sorry, it will be 0 to 1 x square. What is the value of x fx? This is equal to a, and a is 1 by 6 dx plus 1 to 5 x square into 1 by 12. So this implies ex square is equal to twice of 1 by 6 into x cubed by 3. Limits are from 0 to 1 plus 1 by 12 x cubed by 3. Limits are from 1 to 5. So this is equal to, we can take out 6. And we can also take out 3. So 6 into 3 is 18. You can add 2 upon 18. Here you will get 1 cube minus 0, so you will get 1 over there plus. So we have taken out 18, so 36. So 1 by 2 will be here. It will be 5 cube minus 1. 5 cube is 124, 125 minus 1 is 124. So this is simply equal to 2 upon 18 is 1 upon 9. 1 plus 125 minus 1 is 124. 124 divided by 2 is 62. So 63 by 9, this is 57. So we can note it down. So we have a ex square is equal to 7. Now a is equal to 1 by 6, b is equal to 1 by 12. Now these things are non-zero. Now we need to calculate EQ square, and it has been given that the representation levels are the midpoints of the diffusion boundary. So the representation level will be 0.5 to and definitely for a equiprobable representation level 3 must be a diffusion boundary, and midpoint of 3 and 5 is 4. So 0.5, 2 and 4 are representation levels. Similarly, we will have 3 representation levels for the negative values, minus 0.5, minus 2 and minus 4. So these are the 6 representation levels. Again, x and x cube both are symmetric, so q will be also symmetric. Now what will be eq square? Eq square is equal to minus infinity to infinity q square x cube dt. So this is equal to minus infinity to infinity x minus x cube whole square fxx dx. So since x and x cube are symmetric, fxx is symmetric, so we can write it like this: twice of 0 to infinity x minus x cube whole square fxx. So this is like what will be eq. So we can write it like this: q into the decision boundaries are from 0 to 1. Now what is the value of x cube for 0 to 1? It is 0.5. And what is the value of fxx for decision boundary 0 to 1? This is equal to a. This is equal to 1 by 6 dx plus 1 to 3 x minus 2. The representation level is 2 square into 1 by 12 dx. Its height is 1 by 12 plus 3 to 5 x minus 4 whole square into 1 by 12 dx. Now this will be equal to twice of, so this is simply equal to 1 by 6 x minus 0.5 cube divided by 3, the limits will be from 0 to 1 plus 1 by 12 x minus 2 whole cube divided by 3, the limits will be from 1 to 3 plus x minus 4 whole cube by 3, the limits will be from 3 to 5, and of course there will be a factor 1 by 4. Okay. So let's solve it. We can take out 6 outside the big bracket, so it will be 2 upon 6. We can also take out 3. It will be 2 upon 3 into 6. If you put 1 over there, so 1 minus 0.5 is 0.5 cube. 0, if you are putting 0 over there, 0 minus 0.5 is minus 0.5 cube, and minus are plus. So there will be a factor 1 by 2 over there, because we have taken out 6 and 3. So there will be 1 by 2 over there. 3 minus 2 is 1 cube, and minus again it will be 1 cube plus 1 cube plus 1 by 2, 5 minus 4 is 1 cube plus 1 cube. So this is equal to 1 by 9. So this is 1 by 8. 0.5 cube is 1.2 cube. So 1 by 8 plus 1 by 8 is 1 by 4. This is 1 and this is 1. So this will be equal to 2. 4 to the 8 plus 1, 9 by 4. So 1 by 9 into 9 by 4. So this is equal to 1 by 4. So we have calculated Ex square, we have calculated Eq square. Now we can easily calculate SNR. So this Eq square, this is equal to 1 by 4. Now what about SNR? SNR, this will be equal to Ex square divided by Eq square. So this is equal to 7 divided by 1 by 4, so this is simply equal to 28. 28 will be the answer. So option D is correct. Now coming to the last question. It's given the amplitude of a random signal is uniformly distributed between minus 5 and 5. So we can easily draw the PDF for this random signal. So it is uniformly distributed between minus 5 and 5. So its span is 10, so its height will be 1 by 10. Right. And for the quantization noise, The signal to quantization is required to uniformly quantize. So this is the case of uniform quantizer. So the PDF for the quantization noise, this will lie between minus delta 2, delta by 2 to delta by 2, and site will be 1 upon delta. Right. So Ex square, this is simply equal to A square by 12. And what is A? A is the span. The span of FFS, the span of this uniformly distributed function is A, which is A square by 12, which is equal to 100 by 12, because A is equal to 10. And EQ square, now this is a standard result for Ex square for any for uniformly distributed function. So this is equal to delta square by 12. So this implies what will be SNR? SNR will be equal to A square by 12 divided by delta square by 12. So this is equal to 100 upon delta square. Now it has been given that SNR is equal to this SNR. This is equal to 43.5 dB. So this implies 10 log to the base 10 Ex square divided by EQ square. Now this is equal to 43.5, or Ex square divided by EQ square. Now this is equal to 10 raised to power 4.35, and we can easily calculate it. So 10 raised to power 4.35, this is equal to 22,387.2, or this implies, what is Ex square by EQ square? Now this is equal to 100 upon delta square. 100 upon delta square, this is equal to 22,387.2, or this implies delta square is equal to 100 divided by 22,387.2. So this implies delta is equal to, you may calculate it, it will come out to be approximately equal to 0.0668. So option C is nearest to it. So option C is correct. So that's all for today's class. And this class is in continuation with what I have just taken. Actually, there was some problem with the net, and the class was interrupted, and I am not aware of it. So I have just repeated the solution for this the last 6-7 questions. So that's all for this topic. Get questions. The problems of sampling and quantization that have been asked to GATE. So in the next class we will start with the next unit. So that's all for today. Have a nice day.